All right, so welcome, guys. Oh, I can't pick up the pen. Okay, so with this warm-up, what I would really like you to do right now is take out your phone or a timer or something and set a count up timer, like a stopwatch, and try this out and see how long it's going to take you. Okay, so I'm not going to talk. I'm going to work through it, and I'm going to set a timer. So what I would do right now is I would pause the video, try it on your own, and then see what I do. All right, so that took me 1 minute and 55 seconds, right? And then I can even check my answers, right? Like I can put my calculator in radian mode and check all the ones that have radians, right? So the sine of 7 pi over 6, oops, leaves -1/2. Oh, I screwed up. Look at that. Right? Because this is in quadrant. This is like a reference angle of pi over 6 in quadrant. What is that? 3. So it should have been negative. Right? So then maybe, I have to make a note to make sure I'm paying attention to stuff like that. What about the tangent of 3 pi over 2? Undefined. Great. Got it. The secant of negative pi, well, what is the cosine of negative pi? And then do 1 divided by that. Oh, -1. Got it. Cotangent of 150. So, well, what's the tangent? Well, you know what? I think I'm going to finish with the radian ones first. What's the cosine of negative pi over 2? 0. Great. The tangent of 7 pi, over 4 is -1. The sine, now I'm going to change mine to degrees. And I guess I could easily just be looking at the unit circle to check this, but it's okay. What's the tangent of 150? And then 1 over that. I get -1.7 blah, blah, blah. Is that the same thing as the square root of 3? So look at that. I brought a negative again. Right? So that's technically wrong. Right? Like I must need to watch out for those negatives. Right? So that is not great. The sine of 225. Let's see, is that the same thing as 1 divided by the square root of 2? Yep. Right, and I didn't forget my negative there. Sine of 330 is -1/2, got it there. Cosine of 90 is 0, 1 over that is undefined. And then the tangent of 210, and then 1 over that, I get 1.732 blah, 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 which is the same thing as the square root of 3 divided by 3? No. What did I screw up here? Oh wait, why am I doing 2 over? I shouldn't be doing 1 over. Sorry. I'm just doing the tangent of 210. I was just thinking through it of sine over cosine. So this is correct. So I would have just gotten an 8 out of 10 on a speed trig quiz. Right, if this was a practice speed trig quiz. And one of the things I'm asking you to do this week is a practice speed trig quiz. And I mean, you can take it as seriously as you want to take it. I do encourage you to do it. I think it's great practice. You have more than one attempt. And it gives you a variety of practice with this. And you can really think through, like, there are almost multiple choice questions, right? Like, I maybe could have spent a little bit more time, like 1 minute and 55 seconds. I probably could have checked over my work before I said, hey, let's turn this in. So this is an example of that. So we'll see how you did. Grade yourself. Just be self-aware. And I think that's a great place to be right now. So the objective of this lesson is we're actually going to be unwrapping the unit circle. So we've been sticking with the circle. We're going to be using our knowledge of the unit circle and the coordinate points in order to sketch the graphs of trigonometric and circular functions, sine, cosine, and tangent. Our main focus is going to be sine and cosine. We're not going to do too much with tangent. And then labeling some critical points and looking at what those shapes look like. Some of you that have been attending office hours have spoken to what sine and cosine look like. You've seen, like, you've looked it up, which is great. So keep in mind that there's not a ton that I have with practice for this, but I do have like a capture sheet that goes along with this if you want to print it out and work with it, or if you want to print out the PowerPoint, that works as well. But what I would really encourage you to do is after this video, kind of move on to the next one. This is just like an introduction. So we've got this unit circle, right, with all these values filled in. You can make up your own speed trig quizzes if you would like. So what we're going to be doing is we're going to start off, and if you remember, your x values represent cosine, and your y values represent sine at each one of these points, right? So these are my sine values. And we're going to start off by graphing sine. I don't know why I'm circling them all. Right, so these are the points I'm going to be graphing. My input is going to be my degrees or my radians, and my output is going to be the sine of that angle or the sine of that radian at that point. So let's see what we've got. Let's unwrap the unit circle. So we're going to define the variables. The independent variable is either theta, which would be degrees, or x, which would be radians. And I would definitely write this down so that you just know if you're working in degrees or radians. Right, and you might want to reference this later on. The dependent variable is the sine value of the angular arc right now, right? We're going to work with sine first. Fill in only the sine or the y values around the circle, right? So I only care, I'm not going to fill this all in, but I only care about the y values around this. So for instance, if we were working in degrees, at 0 degrees, I only care that this is 0, right? Like my input is 0, my output is 0. My input is 30, my output is 1/2. My input is 45, my output is 1 over root 2. My input is 60, and I'm filling out more than I need to probably, root 3 over 2. My input is 90, my output is 1, that idea, okay? So we're gonna start with quadrant 1. Okay, so these are gonna be quadrant 1 values. So I'm gonna start with 0, pi over 6, pi over 4, and pi over 3. We're gonna work in radians right now. Well, I've got it up here, right? At 0, my output is 0. When my input is pi over 6, my output is 1/2. When my input is pi over 4, my output is 1 over root 2, or root 2 over 2, which I'm going to approximate to 0.707, just for the purposes of graphing. We're not ever going to be really referring to that value, it's just for the purpose of graphing. And then when my input is pi over 3, my output is root 3 over 2, which is about 0.866, blah, 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 blah. Okay? And then you can kind of see what's happening with these values. Oh, look, they're increasing, right? So in quadrant 1, my sign is increasing. Let's look at quadrant 2. My quadrant 2 values are going to be pi over 2, right? That's a boundary angle. And then I've got 2 pi over 3, 3 pi over 4, 5 pi over 6. Well, when my input is pi over 2, what's my output? What's that boundary angle? The sign is going to be 1, right? So it was increasing. We got to 1, and then what's going to happen? At 2 pi over 3, it becomes root 3 over 2. At 3 pi over 4, it's 1 over root 2 or root 2 over 2. Right? So I've got some repeating values now. At 5 pi over 6, I've got 1/2. Oh, so in quadrant 1, it was increasing. In quadrant 2, my y values are decreasing. What's going to happen in quadrant 3? Let's look at quadrant 3. So that boundary angle is pi, right? That one that divides quadrant 2 and quadrant 3. And then we've got 7 pi over 6, 5 pi over 4, and 4 pi over 3. So at pi, my output, my sine of pi is 0. My sine of 7 pi over 6 is 1/2, negative 1/2. My sine of 5 pi over 4 is negative 1 over root 2, or negative root 2 over 2. And my sine of 4 pi over 3 is negative root 3 over 2. All right, so what's happening here? They're still decreasing. Right, so my y values increased in quadrant 1, decreased in quadrant 2, and then continued to decrease in quadrant 3. Well, where do they stop decreasing? Well, at this boundary, right at that lowest point around the circle, at 3 pi over 2. And then we go, and then it starts to go back up, right, at 5 pi over 3, at 7 pi over 4. Think about it like a Ferris wheel. At 11 pi over 6. So at 3 pi over 2, the sine of x is negative 1. That's where it reaches its lowest point. At 5 pi over 3, it starts going back up to negative root 3 over 2, right? It's mirroring the other side. At 7 pi over 4, it goes back up to negative root 2 over 2, or negative 1 over root 2. Then it goes up again to negative 1/2. Right, so now my y values are increasing. So they're increasing in quadrant 1 and 4, decreasing in quadrants 2 and 3. So if you noticed, we never went below negative 1 and we never went above 1. We stayed within that, right? Think that, oh, that's the radius, right? So when we're graphing this, we started at 0, 0, right? The sign values. Now I'm just plotting the points. We went up, we went up, we went up. Oh, there was quadrant 1, right? We went up all the way to 1. And then it started decreasing, right? We noticed in quadrant 2 it was decreasing and decreasing until we got to this point, right? And then we were back to 0. This was like at pi. On the left side of the circle, we were back to a height of 0. Think about sine as height. And then it continued to decrease, right? And we noticed that it decreased all the way through quadrant 3 until it got to negative 1 at that boundary. Then it started increasing again. And increasing and increasing. Right, until you made a full rotation and you started where you ended, right? So this is one full rotation. This right here, what you're looking at, is what a sine graph looks like. Like this is a sine function. So some characteristics, right? So here is a sine function. Here's one rotation around the circle. What is the domain of this? What values can you put in for x? Well, in all reality, a sine function usually has a domain of all real numbers. In this one, it's restricted, right? Like when we graphed it, we just graphed one rotation, which was 0 to 2 pi. But it can realistically be all real numbers. It just depends on what we're working with, right? Like if I gave you no restrictions, you would just, the domain's all real numbers. What about the range? What values do you get out for sine of x? Well, it never goes below negative 1, and it never goes above 1. Right? It always stays within that range. Negative 1 to 1, it kind of just bounces back and forth. It's like bounded by those two values. What are the x-intercepts? Well, there was a lot. Like we saw one at 0, 0. Like where is the sign of x equal to 0? We saw one at 0, 0. We saw another one at pi 0. Right? It's almost like saying, well, where's the height 0? Think about the circle. The height's 0 at this point and this point. At 0, at pi, at 2 pi. And that's going to keep going. Right? Isn't it going to be 0 when we get to 3 pi? Like, you can keep going around. Those are, coterminal. Right? At 4 pi, 0, and so on. So it's really that you're doing, it's pi n 0, where n is an integer. Right? And it can even be negative pi. Like I could go to the left also. In this case, when we're just looking at this one loop, it's at 0, 0, pi 0, and 2 pi 0. What about the y-intercept? There's only one. It's a function. Right? In this case, it's at starting point at 0, 0. Right? What is the sign of 0 is really what that's saying. When your input is 0, what's your output? That's the y-intercept. What's the maximum or the minimum? Well, think about the range. The maximum is going to be 1. The minimum is going to be negative 1, right? Here's your maximum. Here's your minimum. Increasing? Well, we talked about this, right? It's going to increase in quadrant 1 and quadrant 4, right? Oh, quadrant 1 is between 0 and 3 pi over 2. I'm sorry. Quadrant 1 is between 0 and pi over 2, and quadrant 4 is between 3 pi over 2 and 2 pi. Right? I'm sure that will repeat anytime you get to quadrant 1, even if it's past that 2 pi, right? So from 2 pi to what is that? 5 pi over 2. It's going to increase again. We can think about coterminal angles and going around more than once. There, where is it going to decrease? Well, we said it was decreasing in quadrants 3 and quadrant 2 and quadrant 3. So from pi over 2 all the way to when you get to 3 pi over 2. Right? And that keeps going, right? We will find more intervals in which that would happen. Concave up, concave down, right? So it's going to be concave up from pi to, in this case, 2 pi, right? This concavity, it's concave up there. Where's it concave down? We don't talk too much about this, so I wouldn't worry. From 0 to pi, it's changing concavity. That's what the point of inflection is at pi 0. At this point right here is where it changes. You will see that. What about symmetry? Oh, sorry. Oh, darn, it erased it. I can't fold this over anything, but what this is called is it has rotational symmetry, right? Like if you were to take the screen, and I can't do this right now, but if I were to take this and turn it upside down, if you rotate it around this point, if I just were to spin this graph upside down, it would look exactly the same. So it has rotational symmetry about this point. Okay. Let's take a look at cosine, right? So that's what sine was. Let's take a look at cosine. So we're going to define the variables again. Remember, theta is degrees, x is going to be radians. Now my dependent variables are the cosine value of that angle or that arc. And we're going to fill only the cosine. Oh no, this has a mistake. What should this be? This should definitely be an x. The x values are on the circle. Right, so I only care about, at 0 degrees, this is 1. At 30 degrees, this is root 3 over 2. At 45, this is 1 over root 2. At 60, this is 1/2. Like those, I care about the x values here. Okay, so we're again going to work in radians. So we're going to start with quadrant 1. Let's see what happens. So we've got 0, pi over 6, pi over 4, pi over 3. What are my x values there? Well, we got 1, Root 3 over 2, 1 over root 2, and 1/2. What's happening to my x values? Oh no, it goes all over the place. This should be an x. I hope that's my last typo. X value, oh no, wait. No, it's y values, I guess. I guess it should be y values. Can I just erase my pen? Just pretend this didn't happen. Erase pen. It is the y values because these are my output values. So right now they're decreasing, right? They're going, I started at 1 and they're getting smaller. What's going to happen when I get to quadrant 2? Right, so I've got pi over 2 as my boundary angle, 2 pi over 3, 3 pi over 4, and 5 pi over 6. And what are my outputs? 0, right? So we decreased all the way to the point that we went from 1 to 0. Now it's negative 1/2, negative 1 over root 2, negative root 3 over 2. So they're still decreasing, right? So this was decreasing in quadrant 1 and quadrant 2. What's going to happen in quadrant 3? Pi is my boundary angle. Will be 7 pi over 6, 5 pi over 4, and 4 pi over 3. So when we get to pi, your cosine value is negative 1. So we went from 1 all the way to negative 1. And now what are we going to do? Oh, we got bigger. It got bigger again. It got bigger again, right? So now it's increasing, right? We're still in the negatives. We haven't even gotten to 0. But we know we get to 0 on the next point, on the next boundary. So these y values are increasing. So I decreased in quadrant 1 and 2, and I'm increasing in quadrant 3. What's going to happen in quadrant 4? 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. Oh, you got to 0 now. Now it's 1/2. Now it's 1 over root 2. Now it's root 3 over 2. I'm increasing again, and I'm going to increase all the way to the point that I get to 2 pi, which is 1, right? That was coterminal with 0. So I still go from negative 1 to 1, right? I never went beyond that, but I started in a different place, right? Like at 0, my cosine was 1, and then it decreased, and it decreased, and it decreased, and it decreased to 0, right? That was like where I ended on that first boundary. And then it kept decreasing. It went negative all the way to the point that we got to negative 1 when we got to that next boundary angle, right? So from 0 to pi, half the circle, I decreased from 1 to negative 1, and then we started increasing again, and increased, and increased. And increased all of quadrant 3 until we got to that boundary was at 0, and it kept increasing, and increasing, and increasing. Right, all the way to 2 pi where it was back where it started. So this is one full rotation of cosine. So fun fact, and you'll get to this eventually, but a cosine graph is just a transformation of a sine graph, right? They're both sinusoidal functions. But you can think that cosine starts at the highest point, whereas sine starts at the middle, for now to differentiate between the two. So this is what a cosine graph looks like. And I have the arrows on the end because technically it keeps going. This is y equals cosine of x. What's the domain of this? Technically, it's all real numbers again, right? If we just wanted to look at that one rotation that we graphed, it would just be from 0 to 2 pi then, right? It kind of just depends on what the question's asking it. What's the range? Well, again, the range is from negative 1 to 1. Where do these x-intercepts? So where was the cosine of x equal to 0? That was when I was at, if you're around the circle, the highest point and the lowest point, because you're not going left or right at all, right? And cosine has to do with x. So the x-intercepts would be at, what is that, pi over 2, 0, and 3 pi over 2, 0, right? In all reality, it's like I can do pi over 2 and add or subtract pi times some number, 0. Right, it's going to keep happening every single time. I could start up here and go halfway around the circle, halfway around the circle, halfway around the circle, and I'm going to get to another x-intercept every single time. Right, there's always going to be that pi difference. This is your first one that happens, and the difference here is you're adding pi. If you add pi again, If I subtract pi, you're going to get to another x-intercept. What about the y-intercept? Well, that's like your starting point, right? Think, well, what is the cosine of 0? It's 0, 1, right? There's only going to be one of them. We're dealing with a function. Maximum, well, the maximum is still going to be 1, and the minimum is still going to be a -1, right? It had the same range. Because it's really the same graph, just manipulation. Where is this one increasing? So, well, we are decreasing in quadrant 1 and quadrant 2. It was increasing in quadrant 3 and quadrant 4, right? It went from -1 at that boundary to 1 when we got back to 2 pi. So it's increasing from, what was that, pi to 2 pi. It was decreasing in quadrants 1 and quadrant 2, which was 0 to pi. Right, and then we could do that same interval, right? Like it's going to then, it would start decreasing again from 2 pi to 3 pi, and it would increase from 3 pi to 4 pi, right? We can keep going around and around with that. Concavity, it's concave up from, it's pretty much concave up this whole time, isn't it? I don't want to talk about this very much. I don't like this question. It like changes concavity at these points. Right, so it's going to be like concave up from, what are those zeros? 3 pi over 2 to 3 pi over 2. And then it's concave down, I mean, in this case, from 0 to 3 pi over 2. I'm sorry, 0 to pi over 2. And again from 3 pi over 2 to 2 pi. And then that would repeat, right? So it's like, this keeps going with that cycle. That was a terrible drawing. Which means that in this case, I have a point of inflection at pi over 2 and at 3 pi over 2. I would not worry about this information at all. And then what kind of symmetry does this have? It's got some reflectional symmetry going on, right? If I were to draw a line here, I have a line of symmetry. We didn't talk about even and odd functions this year, so this will come up more next year. But if you have an interest in looking that up, my pen is not going so great today, even/odd functions, to look at rotational and reflectional symmetry. A cosine function is considered an even function, and a sine function is considered an odd function if you want to look that up. And it has to do with, this has reflectional symmetry. But again, I wouldn't worry about this either. I'd say these are the key characteristics we are going to be talking about. All right. Let's take a closer look. This is just fun to do. So this hyperlink is in this PowerPoint. If you have it opened, you can click it and play around with it. So I'm going to start with sine, right? And so sine, we're going to focus in on these y. So you can see the sine ratio, and the hypotenuse is 1, so it's always over 1. So what I'm going to do is I'm going to drag this around, and you can see, right? So it's like the sine is starting right there. If I had started it, and I can go back, if I started it right here, I get that 0, 0, and it goes up. This is so cool. And you can see what's happening. The sine gets to 1, and then it starts going back down. Like I'm focused. Oh, I pointed with my finger. I'm focused right here. Goes back down. Gets to 0. Right? And it's only graphing that one time around, but that's kind of fun to look at. I can make this bigger. Oh, nice. Can I play it? Whoa. Right, and then it comes back to the beginning. Okay, pause. Let's look at cosine. I guess I can do them all. I'm going to do just cosine first though. So I want to start it here. So it starts at the top, and then it comes down. And then it goes around. All the way back to the top. Right, that's one full rotation. So we can look at sine. Let's play them both. You can see like what's happening simultaneously, and they intersect. Right, they intersect at that 45-degree angle. That's where it's going to be the same. And they're going to intersect again when they get down here, right, at 225, right, or at 5 pi over 4 right there. They intersect because they have the same value. So cool. Okay. We have not, no, stop. We have not looked at tangent at all, but I'm going to show it to you here, and then I'm going to show it to you in a moment on the PowerPoint, and we're going to finish up with that. It's not as critical. We're not really going to be doing very much with it. You'll do more with that next year, as will you do more with the reciprocal functions next year. We're not going to graph those this year. So tangent. So I'm going to start it here. So what's the tangent of 0? Remember, tangent is sine over cosine. So if you think about the circle, this point right here is going to have a sine of 0 and a cosine of 1. So you're going to start at 0, 0, right? And the tangent, what happens when you get up here? It's undefined. Well, what happens if something's undefined? Forms an asymptote, right? And then you can see kind of what's happening. So it's never going to touch this line of pi over 2. Oof. Right? So you don't see it right now. You're going to in a second. It's going to come back up. Because right here, tangent's negative all along here until it gets to pi, right? And then in quadrant 4, remember all students take calculus. I'm sorry, quadrant 3, take calculus. Oh, it becomes positive, right? It was 0 here. And then it's undefined again. So it's approaching that asymptote. And then it's again. So like one full rotation looks like this, which we are going to look at right now. Something fun to play with if you want to check it out. Okay. So let's look at tangent. So we're going to fill in these values for tangent. So at 0, it's 0, and I just have it going around one time. Terrible color choice, Miss Gallard. What a nice red. At pi over 6, think sine over cosine. Right, at pi over 6, you're going to have 1/2 over root 3 over 2, which is going to give you 1 over root 3, which is approximately what? 0.577. Pi over 4, oh, it's going to be 1. Pi over 3 is going to be root 3 over 2 over 1/2, which is just going to be root 3. So this one goes outside 1, right? So it's going to give you 1.732 about. At pi over 2, it's undefined. At 2 pi over 3, it's going to be this, right? But it's going to be negative 1.732. At 3 pi over 4, there's obviously a ton of values in between there. We're just looking at the special angles. At 3 pi over 4, we're going to have negative 1. 5 pi over 6, we're going to have negative 0.577. Notice I'm just doing this. Right, this is negative root 3. This is negative 1 over root 3. At pi, we're going to have 0. 7 pi over 6, now we're in quadrant 3. This is where its tangent gets positive. At 7 pi over 6, we're going to have 1 over root 3, which is about 0.577. I'm thinking reference angles. That's why 7 pi over 6, I'm linking it back to pi over 6. And just thinking about it, is it positive or negative? 5 pi over 4 is going to be positive 1. 4 pi over 3, link it back to pi over 3, and it's going to be positive. So you're going to have root 3, which is about 1.732. 3 pi over 2, it's undefined again. So you have two places it's undefined. 5 pi over 3, so now I'm in quadrant 4, and tangent's going to be negative, so these are all going to be negative. And this will be 0. 5 pi over 3 is going to be negative 1.732 or negative root 3. 7 pi over 4 is going to be negative 1. And then negative 1 over root 3, which will be about negative 0.577. And then let's sketch this. So I'm going to actually start with the asymptote. You know what? I'm going to start by drawing all these in. So I'm going to go to 2 pi. So let's break this up. So here's pi. Here's pi over 2. Here's 3 pi over 2. Aren't those where my asymptotes are? Ooh, look at that. There's an asymptote at x equals pi over 2. It was undefined there. Here's another asymptote at x equals 3 pi over 2. It was undefined there. It was 0 here, and here, and here. What about in between here? What was it at pi over 4? Pi over 4, it was 1. I'm going to have 1 and negative 1. What was this? 3 pi over 4, it was negative 1. 5 pi over 4, it was positive 1 again. And at 7 pi over 4, the computer's having some issues, it was negative 1. Right? And then I'm going to kind of sketch these in. So like right here would be pi over 6 and pi over 3. Pi over 6 was 0.5, like it's like right there. And then this is going to be over it. Right? So I'm going to have something that looks like this. Oh, I totally missed. Here, this is what's partway between pi over 2 and 3 pi over 4. 2 pi over 3, it was negative root 3, so negative 1 point something. So it's going to go like down here. This is negative 0.577 about there. This is 7 pi over 6. It was like 0.5 something. This is 4 pi over 3. It was like 1.7. Oh, wow. I'm struggling with this drawing. And then this last one, I end up, this was, what is this? 5 pi over 3 was like negative 1.7 something, and this was there. And I'm approaching those asymptotes. And that is one rotation of it. And obviously it keeps going as you go more. We don't work as much with this, but it is good to recognize what it looks like and know that you have these asymptotes, and this will be something that you're going to use more in the future. Okay. So this is what we just looked at. So we looked at the graph of sine, so knowing these are the parent functions, right? So in the next lesson, we're going to be doing more. We're going to be looking at transformations of sine and cosine. Transformations of sine and cosine. Right, so know that this is cosine and this is sine, and then do know that this is a tangent function. Right, and knowing that this is that one rotation from 0 to 2 pi. And also keep in mind, like we looked at these in terms of radians, but you could have something that said, oh, this is 45 degrees. Oh, this is 90 degrees. Oh, this is, what is this? Why am I having a moment? 135 degrees. Oh, this is 180, right? Like you can look at it like that as well. And it's good to work with that because we are going to be working with both. Okay. So what we did was we used our knowledge of the unit circle to kind of take things off of the unit circle, right? And to unravel or to unwrap the unit circle to sketch trig or circular functions of sine, cosine, and tangent, and label some critical points and talk about some important characteristics. And if you're uneasy about some of those characteristics, maybe think that I'm looking at what's the domain, what's the range, min, max, increasing, decreasing, and intercepts are really what I'm going for. If you were thrown off by concavity and point of inflection and symmetry and stuff like that, don't worry about it. But if you do want to take it a step further, I encourage you to look up even and odd functions. Very, very much so. I think that is, well, you are going to be doing that in pre-calculus, but I think if you're looking for an extension, that's great. So what I would encourage you to do at this point is review the unit circle, do some practice with that, and maybe go ahead and take the speed trig quiz. Remember that it's practice. You can take it as seriously as you want to take it, but I encourage you to take it seriously to challenge yourself and get good practice for yourself as you're moving forward with this. No judgment if you don't do great the first time, but I would love to, I think it would be nice for you and me and all of us to see growth as we go through this. And then I would suggest you move on to the next lesson where we're going to need a lot more practice and we're going to work with some of these transformations. All right. Thanks for watching, guys.